Hey guys, this is Mr. Lowry. This is kind of what we covered in our lesson from day one on the week starting with March 15th. So if you're an A-Day student, this was taught on March 15th. If you're B-Day, this will come on March 16th. I'm just going to kind of go over some key concepts here and show you where you can find your homework in the book and some other things. Okay, so first off, we changed our books out to this book, Algebra 2. If you weren't here today, A-Day or B-Day, I've posted this section as a PDF in the assignment. So you can actually just go back into the PDF and open it up, and you can find it there. And then next time you come to class, I'll give you a hard copy that you can take home. If you were in class, then you should have a textbook, and you can kind of find some of this stuff in there. So this is section 2.3. They call them lessons here, so lesson 2.3, I guess. This is chapter 2, lesson 3. Basically, and this is an introduction to functions. So we're switching gears, we're switching out of geometry, we're getting back into algebra, and we're going to start with just kind of a review of functions. So this is maybe some stuff you learned last year. If you took SM1 here at UCAS, then you definitely learned about functions in SM1. Okay, so there's a couple definitions in here that are really important, and I want to kind of point those out to you. Okay, the first one in the book is definition of a function, okay, and that's here. And if you weren't here today, you're going to want to write that down in your book. Okay, that's page 102. So it says a function is a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. Sometimes we use language like inputs and outputs instead of first variable, second variable. So when it says a relationship between two variables such that each value of the first variable, I sometimes will say input variable or x variable is paired with exactly one value of the second variable. That's usually the output variable or y. Okay? And then it talks about domain and range. Okay, so the domain of a function is the set of all possible values of the first variable. In other words, all possible values of the input variable or the x variable. And the range is a set of all possible values of the second variable or the y variable or the output variable. Okay, what I wanted to point out to you is that there's this definition of function right here, and then on the kind of a page later, there's a definition of a relation. And the definitions, they look almost exactly the same. Okay, so I want to point out to you how they're different so that you can understand what that looks like. Okay. So this one says a relationship between two variables such that each value of the first variable or input is paired with one or more values of the second variable or output variable. So x and y. Each value of the x variable is paired with one or more values of the y variable. Okay, so this is the key right here. One or more values for a relation. Exactly one value for function. Okay, see how the wording is almost exactly the same, but this says exactly one, and then relation says one or more. Okay, and then it talks about domain and range. The definitions for domain and range are almost identical as well. Okay, so keep that in mind. Let me show you a quick example here. Now, the way a relation or a function is really just a relationship. It's a way of pairing x's and y's, or a way of pairing inputs and outputs. And there's several ways to represent that pairing. Okay, so notice a table will pair inputs and outputs, right? X's and y's. But not just a table, right? You can also see that with a graph, because a graph also pairs x's and y's, right? It's got an x-axis and a y-axis. So each point is a pair of variables, an x variable and a y variable. Okay. Another way to represent a function would be a list of points. So if you flip over a couple pages to page 108, you'll see that there's relations and functions represented like this, as a list of ordered pairs, or as a table, or as a graph. Okay, all of these are relations. In other words, they're showing a pairing of x and y values. Sometimes that's written like a coordinate, sometimes that's written like a table, sometimes that's written as a graph. So all of these are relations because they're a pairing of x and y values. Now, some of them will be a special type of relation that we call a function. And a function has a little bit of a difference. And again, the wording comes down to relation. Each value of the first variable is paired with one or more values of the second variable, where function, each value of the first variable is paired with exactly one. Sorry, cut that off. Each value of the first variable is paired with exactly one value of the second. So example 1 here is actually a pretty good example. Notice in each one we have pairings of x's and y's. So in here, all the x values, none of them repeat. So each input value, each x value, is paired with exactly one y value, right? In other words, none of the x values are repeated. Now there are some y values repeated, and that's okay. What we want to make sure is that each input value, each x value, is matched with exactly one y, and it is. Okay, in this case though, you'll notice that there's repeated x's. So the input value 3 is matched with 7 and 8 and 10. So this input value is matched with more than one output value or more than one y value. Okay, so that's kind of what it says in the solution here, but written out. Here, each input value, each value of x, is paired with exactly one y value. So it's a function. Okay, it also happens to be a relation because a relation is a special type of function. These are both relations. Okay, but this one happens to be a special kind that we call a function. Okay, so B, notice that we have repeated x values. So the value 3 is paired with more than one y value. So it's not a function. It is, however, a relation. Okay, so for B, each value of the x variable is paired with one or more value of the second variable. That's true, right? 3 is paired with one or more value. It's paired with 3. So it is a relation, but it's not a function because the wording of function says it has to be paired with exactly one y value. Okay, so that's kind of the difference. Now remember that these things can be represented in different ways. These relations or functions can be represented in different ways. So you can also represent it as a graph. Okay, so here's the trick on the graph. Sorry, let me get the camera right. For a graph, instead of looking for repeated x's, you're going to look at you're basically going to do what's called the vertical line test. Okay, so another key concept here in blue, key concepts, key terms are in blue. And what the vertical line tests say is draw a vertical line or draw several vertical lines through your graph, and if you can hit the graph twice, it's not a function. If you can't hit the graph twice, it is a function. Okay, so here when we do the vertical line test, the red part is our function. Okay, the green represent the lines that we would draw to do the vertical line test. So the vertical line test is just draw a bunch of vertical lines and see how many times you hit your graph. Okay, notice that this vertical line hits the graph in 1-2 places. Okay, that means that the input 3, right, that this is 3 on the x-axis, has 2 outputs. It has this output and that output. So it's almost like seeing that repeated 3 again. Okay, so this guy is not a function because it fails the vertical line test. This vertical line represents, when it hits the graph twice, represents 2 outputs for a given input. This one over here, though, when you draw those vertical lines, vertical line, there's nowhere you can draw a vertical line that will hit the graph more than once. All right, this only has 3, but if you imagine drawing, any vertical line, none of those lines are going to hit the graph more than once. Okay, so the vertical line test, draw a bunch of vertical lines through your graph. If any of them hit the graph more than once, it fails. It's not a function. If you can't find a single place where a vertical line will hit the graph more than once, then it has to be a function. It passes the vertical line test. Okay? So let's look at a couple of your homework problems here, and then we'll talk about kind of domain and range. All right. So your homework starts here at 22, and it says state whether each relation represents a function. Okay, so what we're looking for here on 22 through 25 is we're looking for basically repeated x values. Okay, so in 22 we got this input is matched with one output, this input is matched with one output, and this input is matched with one output. So this one's going to be a function. That one's fine. In this case, in number 24, notice that the input of 1 has 2 different outputs. So this input 1 is not matched with exactly one output. It's matched with 2 outputs, which means it's not a function. It is a relation. That's okay. It says it's a relation. All of these are relations. But it's not the special kind of relation that we call a function. Okay? So what we're looking for here in this problem set is repeated x's. Are there any repeated x's? If there are, we have a problem. It's not a function. Now, repeated y's is okay. Repeated y's doesn't matter. That doesn't have anything to do with the definition of a function. Okay? Tables, same thing. Again, we're looking for repeated y's. So here in 26, notice the input 2 has 2 outputs, right? So the definition of a function is each input has exactly one output. And we can see that that's not the case here, because this input 2 has 2 outputs. Okay? Now in 27, we see repeated y's, and that's fine. Okay? Does this input have one output? Yes, it does. Does this input have one output? Yes, it does. Does this one have one output? Yes, it does. Does this one have one output? Yes, it does. It doesn't matter if some of those outputs are the same. What's important is that none of the inputs are the same. Okay? So this, I would say, is not a function. This one is a function. Okay? So there's an example there for you. For the graphs, like I just showed you, we're going to do what's called the vertical line test. Okay? So we're going to draw a line. I'm not actually going to draw them because I don't want to write in the book. But you're going to draw a bunch of vertical lines through your graph. And if your vertical line, any vertical line, hits the graph more than once, it fails the test and it's not a function. So check out 32. Boop. There's lots of places where I can draw a line. If I draw a vertical line right here through -2, I'm going to have an output here and an output here. Okay, so every vertical line represents me testing a single input. How many outputs for this input? There's 2. How many outputs for this input? There's 2. How many outputs for this input? There's 2. Every vertical line will tell you how many outputs you have for that input. Okay, most of them have 2, so this is not a function. Okay, similarly here, if you draw a vertical line here, you're going to have 2 outputs for the input of -2. If we draw a vertical line here, you're going to have 2 outputs for an input of -1. Okay, so this isn't a function either. Now some of these are kind